Hi, hello guys, welcome back to my channel. It's really nice to have you guys here. So the topic that we have today, it's multiple linear regression. So it's gonna be like the continuation of linear regression that we did in the last video. So if you have not watched that video, I'll advise you to go and watch that linear regression video so that this won't be hard for you to understand, right? Because in the last video I was able to explain in details what linear regression is and what linear is and what regression is and what linear regression is. Okay, so please, if you are new here and you have not seen that video and you are new to machine learning and all of that, I'll advise you to go and watch it. But in today's class we're going to be looking at multiple linear regression. Okay, so and I think that you guys will love it. So let's just get right into it. Again, just like a recap of what we did in the last class, we talked about linear regression. We did examples of linear regression. We got our data, we were able to design our own linear regression. Okay, so I think the linear regression I would design was to predict student exam score based on their hours of study, right? And it was really cool. You know, we taught the model using our data and we were able to test our model with some values. Okay, so that's really good. Okay, so today's class is gonna be building on that, right? Because we want to enhance our capability of using linear regression to be able to use multiple linear regression. And again, I will explain what that means in a second. Okay, so what are we going to learn today? Okay, so in today's class we're going to learn again our definition of multiple linear regression. What is multiple linear regression and how is it different from linear regression? Okay, so we're going to have some examples of multiple linear regression. We're going to get data, right, to be able to design a multiple linear regression model. Then we're going to design our model again, and we're going to teach our model a multiple linear regression model something to do, right? And what we're going to be teaching our AI model today is going to be very interesting. Is what we do almost every day. Okay, and I think that you guys will like it. Okay, then after that you guys will have and an activity which is going to be like homework, you know, for you to just test the model with different values. Okay, if you guys are ready, I'm ready. Let's get right into it. Okay, so like I said, we're going to be building on linear regression. From the last class, if you remember, we said linear regression is a tool for knowing the relationship between two things that are linear. For example, age and height of a baby are linear, right? So linear regression is you predicting one thing from another thing. So it's one to one. Okay, so you cannot have two or more things predicting one thing, right? So, and this is kind of the visual representation of what we did in the last class, like this, right? So we say that we can get the height of the baby from the age of the baby. So we are saying as the baby grows, like older, the height will go go up, right? And based on that knowledge, we can create a linear regression model to kind of say, okay, if I know the age, then AI tell me the height, right? Because there is a relationship between them because they are linear. Okay, so but I think you guys should spot the issue with this. There is an issue with this. Okay, can you guys spot it? Because we are saying that as the age of a baby increases, then the height will also increase. But have you seen some people that are 12 years old and they are 6 feet tall, and someone is like 25 and they are 5 feet tall? So that means it is not only age that determine the height of a person. There are other factors, right, that determines the height of a person. The sex of the baby. Some males grow taller than some female, irrespective of the age. Then the height of the parent too. If your parents are short, you'll probably be short. Right? Then also the diet of the baby. Like, what's the baby eating? Like, is the baby eating a balanced diet and all of that? So that means we supposed to consider all of these variables. So sex of the baby, height of the parent, diet of the baby. We're supposed to put all of them plus the age in our linear regression model. But again, our linear regression model cannot handle this, because our linear regression model can only take one input and get one output. It can only handle one at a time. It cannot handle different things, right? And most of the things that we have in our environment, it is not only one thing that affect them. Like for example, the height. There are so many things that can affect the height of a baby, right? So that is kind of the limitation of linear regression, and that is where multiple linear regression comes in. Okay, so multiple linear regression is just like one or like two or more linear regression, just as the name says. Okay, so but let's just look into multiple. Okay, so let's see now, what is multiple linear regression? Multiple linear regression is a tool. Again, I'm just giving you guys definition so that you can understand it. This definition is not meant for you to cram it or but if you want to, yeah, you can do it. Multiple linear regression is a tool for knowing the relationship between one thing, right? Knowing relationship between one thing and two or more things, and they call them independent. So like this one is dependent variable, that is the one that is going to change the height, and they call the other one independent variable, but you don't need to worry about worry your head about that. Relationship between one thing, actually it's not just one thing. You can get two or more things from this side, but just for simplicity's sake, let's just assume that one thing, which is the height, then two or more things, which is the independent variable, age, sex, diet, blah blah blah. It is a combination of many linear regressions. Okay, so now assuming that this is our linear regression model, our AI. So our AI for multiple linear regression is able to take all of this input that this guy cannot take, this linear regression. The multiple linear regression can take all of this, and we can program it, we can teach it, and is able to predict our height. Okay, so that's just the difference between multiple linear regression and linear regression. Again, I won't go into deep definitions of regression. I did that last week. Okay, so that's the difference, and the code is pretty similar, right? But we are going to be using multiple linear regression to solve a very important problem. Okay, so hopefully you guys know the difference between multiple. Just on eye level, just know that multiple linear regression is just many linear regression. Just assume that this one is one linear regression, this one is one linear regression, this one is one linear regression, this one is one. So that means this multiple linear regression has 4 linear regressions, and it can continue. It can have 100 or even 1000, doesn't matter. It's based on the number of input, right, that you have. Okay, so we'll soon go to our code right now, but before we go, so our multiple linear regression that we are writing today, we're going to be writing a model to predict temperature. Is that not that cool? It is cool, right? It's really nice, because almost the same thing that the people that our phone uses, you know, to get the temperature, is what we're going to be building today, right? And what we're going to be doing specifically is this, and I will explain. You know, sometimes in winter or in summer, right, you will see that the temperature will read a certain value, let's say 7 degrees, but then they will tell you that, oh, even though the temperature is 7, it actually feels like 3 degrees, you know. So why is that? You know, so like, what is making it that the temperature is much more lower, the temperature feels lower than what it is, right? So that's what we're going to be doing today, right? So we're going to be training an AI model using multiple linear regression that will take this temperature, like the normal temperature reading, and then with some factors wind speed, you know, humidity and all of that, and it is able to predict what the temperature will feel like, even though this is what the reading is about. Okay, so that's what we're going to be designing today. I hope you guys understand the problem that we are going to trying to solve, right? I mean, technically it's not a problem because your phone can tell you that, right? But it's just like a learning process for us to be able to do what our phone is able to do, right? Because our phone is actually pulling that data from somewhere, you know, and that data is from AI somewhere, maybe like Google designed the AI, or Microsoft, or the government, you know, or the weather guy, you know. But we can also design the same thing. Okay, so that's what we're gonna do. So with that, let's get right into the code. But guys, please make sure that you understand the difference between linear regression and multiple linear regression and the problem that we are trying to solve in here. Okay, so this is our code. Hopefully everyone knows how to go to Google Colab by now. Okay, so again, you can just search for Google Colab in your browser, right? Then it will take you here. Then you say, oh yeah, I want to create a new workbook, or or a new notebook, rather, new notebook, new notebook, right? Then after that, then you just rename it to something reasonable, lesson 4. Okay, so now let's get started. So before we go into this, we're going to be using, since we want to predict this, right, so we're going to be using weather forecast data. All right, and this data is actually a real data, right? It's not like automatically generated. It's real temperature and weather forecast data. Okay, so we need data to be able to teach our AI. So I downloaded the data, you know, and the data, I will put the link in the description down there so you can download the data. Okay, but after downloading the data, so like you guys should know the drill by now. So we're going to put our data in our sample data folder. Okay, so after downloading the data in your download folder, so you just come here, so click on upload. So then this is my data, weatherhistory.csv. please, it's CSV, it's not CVS. I've seen some people write CVS. Okay, it's CSV, and it's a little bit large. Well, not really large, but it might take some time based on your system. See, okay, so now we have it. Okay, good, we have our data. So let's just close this for space. Okay, so then you guys remember, we just we need to import some of things that we're going to use. Again, I won't type the code in here. I've already typed the code somewhere, you know, because I don't want to waste time. So but I will just explain the code to you guys. Okay, so we always use this. Okay, so we import pandas, pd, numpy. So like, again, these are kind of code that have been written for us that we can reuse, for data manipulation and all of the things that we need to do. Okay, so make sure that you type it right, and when you type it, then run this. So if you did everything in the right way, then it should have a check mark. So now let's continue our code. So the next thing that we'll have to do, of course, is to load our data, because we need data to teach our AI. Excuse me. So we load weather data, then we see that our data, if you remember, is going to be in our sample data folder. So put this period in here / so sample data, then weather history.cs. Please don't misspell this. I've seen so many people get error because of this, so make sure that you have this written as it is. Then we just, because it's CSV, then we need to read it so that our AI can use it. All right, so we use this, you see. So that's one of the reasons why we import all of this. If we don't have this and we want to read this, then we'll probably have to write hundreds of lines of code. But well, we don't have to do that, because this PD, which is pandas, already give us a function to be able to read CSV. So we just click on this, so everything checks out good. Okay, so now we just want to see what is inside our data, right? And we can do that by saying data.add. So this one is just saying, because the data has, I think, like hundreds of lines of data set, right? But this one is trying to say, give me like the top 4 data, right? I just want to see a sample of what is in my data. So this is what this is saying, data.add. So show me the head of the data. So let's run that. Okay, nice. So you see, so these are all the variables that we have. So we have formatted dates. This is the date. We don't need date. We don't need summary. Precipitation type, we don't need this. So we see we have temperature, right? So this is the actual temperature that we get, and apparent temperature is what the temperature feels like. Okay, and this is what we want to use this data to predict, like to teach our AI to be able to predict, right? Then we have humidity, then we have wind speed, then we have wind bearing, we have visibility, we have loud cover, we probably not use this, we have pressure, and we have daily summary. Okay, some of these we are not going to use them, so we are going to drop them, but this is just good for you guys to see. So what we are trying to use this data to do is, can we train our AI so that our AI will be able to predict the apparent temperature, which is going to be the feels like temperature, based on all of this input. Okay, so that's what we want to do. Okay, so let's go to the next step. So the next step is, like I said, not all of these columns we're gonna use, not all of these. Okay, because this date, we don't need date, we don't need summary. Okay, so these are everything that we're gonna use. So just write data is equal to data, then you put square bracket, then another square bracket, then make sure that you close it. Okay, so now we want to take all the things that we need. We need temperature, we need apparent temperature. Make sure that you type this exactly the way it is in here. If you type this and you don't put space, you're gonna get error, right? Because we are trying to extract this data from here. So what we have here must be exactly what we have here. Please make sure that you put, then this one is just single quotes, it's not this. Okay, it's this. All right, make sure you have this exactly. You can pause the video, right? And I think I have to move it right and left because the screen is big, but make sure, you know what I'm gonna do, I'm gonna do this and it should still work. Yes, so that you can see it in one place. Yeah, so type all of this in here. You don't have to bring this in new line, but if you want to do that, it's fine, but make sure that everything looks right this way. And then after that, we're going to do the data.add again. So that means we are going to lose some of the thing that we don't need. So let's do that. So you see, now we have just the thing that we need: temperature, apparent temperature, and which is also feels like temperature, humidity, wind speed, wind bearing, visibility, and pressure. That's good. So now we have all our data. So what's going to be the next step? Can someone guess? Okay, so there's should I do this one? Yeah, I mean, hopefully you guys don't get confused. Okay, but I'm gonna still do this. Okay, there's something called correlation, right? So correlation is how one variable is affecting another variable. So in our example in here, okay, so correlation means, is the age of the baby affecting the height more than the sex of the baby affecting the height, or the height of parent affecting the height, or the diet of the baby affecting the height? So like we want to know like which of these is affecting the height more, right? That's what correlation is. Like we want to know, oh, now we want to predict this, okay, and we have all of these variables. Which one of these is affecting this more than others? Okay, that's what correlation is. So and when I run this, you guys will see what it is. You know, again, it is good to kind of have understanding of this, right? So that when you are developing your model, you will know which one is affecting your variable more. Oh, so I'm gonna run this. So let me explain this. Okay, so you see, our apparent temperature is what we want to predict. Okay, so now we're going to look at this and we're going to compare it with all the columns, right? So if the value of this and the column is almost close to 1, so that means there is a very strong correlation, meaning that the value of this temperature affect the apparent temperature a lot, right? So you can see for this one is 0.99 and apparent temperature is apparent temperature, right? So this is going to be 1 because it's the same thing. Okay, again, if you're confused, right, it's like a very complex concept, you know, for children, you know, like for young people, right? So just follow me, right? So it's apparent temperature with humidity, you see, is minus 0.6, so that means it's still significant, but it's less than this one, right? Then wind speed, then wind bearing, this is low, 0.02, and this one is the lowest, right? This is just showing you how all of these will affect this. Okay, so it's nothing that we're gonna, like, it's not part of developing the model. It's just for you to have understanding of the data that you are working with. Okay, so hopefully you guys are not confused, but so now you know what correlation means. You know, when you get to high school and college, for young people watching this video, you're going to do something in statistics called correlation, you know. Hopefully this will help you guys. Okay, so that's correlation. So, and I'm gonna do one more thing. Okay, so the reason why I'm doing this, right, so you guys know that this is our data, right, and this is what we want to predict. So since this is what we want to predict, so we have to remove this one from the data and separate it to be in the output, right? So our X are all the inputs, which are going to be this, humidity, and all of this. Then our Y will be this, because that's what we want to predict, and that's what we are trying to do here. Separate apparent temperature into Y, then remove it from X. Okay, then again, make sure that you put everything in order. Okay, So predictors are called variables, and which are everything except this. All right, and the target variable is what we want to predict. Let's run this. That is good. So this one, we've done this one before. This is splitting our data set into test and train, which we should all know that. Okay. Okay, so now we have X. So again, the reason why we are doing this is to train our AI with a certain value, then to test it with certain value. And this test size means that this is like 20%, so meaning that 20% of our data is going to be for test and 80% is going to be for training our data set. That's what this test size means. This is like the same thing as 20% because it's 2 divided by 100. Okay, so we'll run this one. I think I did already. Then we start our model. So this is our model. Again, it's called linear regression again, right? But it is multiple linear regression because we have multiple inputs, right? Which is, you see, multiple inputs, right? So that's why it's multiple linear regression, but we still call it linear regression, but it is multiple linear regression. Okay, so let's do this. There you go. Okay, so we have trained our multiple linear regression with our X train and Y train. So let's now check the accuracy of our model. To check the accuracy of our model, what we have to do is to run our model on X test and Y test, right? So because we're training with X train, Y train, now we want to say, so what this one is doing is we are going to make our model to predict by itself using X, right? And we're going to compare the result to Y test. That's what this is doing. So let's see. Wow, 99%. That's a very good score. So that means our model is really good, right? So now let's test it with some. Okay, before that, let's just print our regression model parameters. Again, if you don't understand it, don't worry about it. Okay, so these are all the parameters that our multiple linear regression model learned to be able to get this accuracy, right? So these are all the gradients, because we are going to have for multiple linear regression, we're going to have multiple lines. So if you remember last time in the last video, I have just one line, right? Because we have just age and sex of, like, height and age of the baby. But now we're going to have different lines, right? And each of the lines, we are going to have their own gradient. And in fact, we have 1 2 3 4 5 6 gradients, and we can see from here we have 1 2 3 4 5 6. So each of these variables, we have their own gradient. Again, if you don't understand that, it's perfectly fine because you are still young. But for people that are experienced in this, they will understand what I'm talking about. But the major thing that we want to do right now, which is going to be part of your homework, is since we have designed our model, let's now test it with new data. And I will explain this. This is how you test your model. Okay, so we want to predict apparent temperature, which is also the same thing as feel like temperature. Okay, so we need to give it inputs: temperature, humidity, wind speed, wind bearing, visibility, and pressure, right? So let's assume that if temperature is 25, humidity is 0.65, wind speed is 20, wind bearing is 80, and this is this and this is this, right? What would be the value of our feel like. So if the temperature on your phone is reading 25 but all of these are reading this, are you gonna feel 25 or not? So let's try it out. So you see, if the temperature is 25 and all of these are this, and you go outside, what your body is gonna feel is gonna be 24.5, right? You know, and let's even say it's a lot windy. Let's say it's 50 kilometers per hour. It's really windy. How is it going to affect our temperature? Let's see. Yeah, so it will feel colder because there's a lot of wind, you know, outside. Okay, so let's say humidity is negative 0.65. so you see it's gonna drop the temperature, and we can see the reason why that is happening if you check the correlation, right? So the correlation between this is negative, right? So that means as humidity and wind speed is increasing, temperature will reduce, right? So but for visibility, as this one increases, temperature will increase. So let me increase visibility. Let's say visibility is 100, then our temperature should go up. So it went up. I think it did, right? So that's 20, so it should go down now. Wait, maybe I'm wrong. So that's 20.396. let's see. Well, I think I'm wrong, but yeah, so I think the visibility is also affecting it negatively, right? But you guys get the gist. So let me if this is like this, it's gonna be very low. Yeah, negative. Yeah, but you see, okay, so you see, this is how this affects so these are the feel like temperature. Okay, so now in summer or in winter, when you get the temperature on your phone, you can come and put it in here, then you get all the temperature, like all the readings of this online, right? Then you put it in here, then it will tell you exactly how you are gonna feel when you go outside, right? So yeah, so I just want you guys to, for your homework or assignment, or you know, try to play with these values, you know, and see how it is affecting the feel like temperature, right? I was thinking that the visibility will affect it positively, but yeah, maybe I'm wrong. Yeah, so okay, so if visibility reduces, it's gonna increase. Yeah, okay, so it's inversely proportional. Oh, okay, that kind of makes sense. So if the humidity reduces, this will also reduce. That kind of makes sense. Okay, so if humidity reduces or wind speed reduces, this will reduce, but if visibility increases, this is gonna increase. Okay, makes sense now. Okay, yeah, so thank you guys for watching the video. So this is the end of this class. Again, we were able to understand the difference between multiple linear regression and just linear regression, and we were able to build our model and taught our model how to predict feel like temperature if we have the normal temperature and we have all this reading on our phone. Okay, so thank you so much for watching this video. We are going to continue in the class. I'm going to learn more about AI model. We are going to still going to learn a lot of stuff, and everything that we are building right now, at the end of the class we are going to build a mobile app. You know, I will help you guys to build a mobile app so that you can put all of this in your mobile app and people can actually use it, right? So I have a separate class for mobile development, right? You can take that class, but if you don't have time, I will still show you guys how to build a mobile app, but I won't give you details, you know, just show you how to do it, and then you just put your AI model in it, you know. Then for example, you know, people can come to your app and say, oh, this is the temperature outside. Then you will now tell them, oh, if the temperature outside is 25, right, and these are all this reading, then when you go outside it's going to feel like 20, you know. So that's the idea behind that. So really cool stuff. And please make sure that you do the code and you do your homework, and then I'll see you guys in the next video. Thank you.